Let's go ahead and start. So from here, we'll press Control, add a page, and we're going to click on 4, whatever you want. You can even type in 4. Then we'll have our input variable of X, our output variable of Y. And then here on the first row, we're going to start putting in some numbers. So these are these random numbers. I'm going to use 5 of them. So 69 and 69. Then coming over here for my Y values, we have 183, 168, 171, 178, and 176. Okay, so I have 5 data points entered into my spreadsheet. From here, what I'm going to do is Control, add a page, and I'm going to add a data and statistics. So when I click on here to signify that this is my x-axis, and click here to signify that this is my y-axis, there's my data. Now, this could be linear, this could be quadratic, this could be exponential. Whatever the best line of fit is, we're going to find that here in just a bit by pressing Menu, Analyze, Regression, and we can do mx plus b. There's your line. This is your line of best fit if it was linear. We could try a quadratic by doing Menu, Analyze, Regression, and going to quadratic, and this would be our equation as far as our line of best fit. This is the graph that kind of goes through all of these points as best to the center of these points as possible, okay? And then our last example, we could press Menu, Analyze, and we're in an exponential unit, so you might have an exponential regression. So here, with your A value, your initial value of 139, your B value, your common ratio of 1, raised to the power of X, this could be your line of best fit, okay? So it all depends upon which one looks the best per se. We are going to talk about correlation coefficients, which is a little bit different as far as calculating what it will be. Let me show you that real quick. So statistics, we're going to do a statistics test. Oops, not there, my bad. Stat calculations. And let's say we wanted to guess that it was quadratic. Okay, so if it was quadratic, my input variable was X, it was Y, and then I would press OK. Now here is your equation. So you have an AX squared plus BX plus C, where this would be your A coefficient that you would put into the standard quadratic equation. This would be your B number that you would put in, and we've done these with linear and quadratic before, and C would go here to 277.982 would go here as far as your equation. This number is what we're looking at. This R squared is equal to this value. It's basically saying that I have 0.512, that if I took the square root of it, because that's equal to R squared, I could find its correlation coefficient, okay? So let's go back to that. It was 0.51247, and that would be its correlation coefficient. The closer this is to 1 or -1, the stronger your correlation is, okay? So when you're doing this, again, I'll come back here and I'll show you from the first row, column C, I can, instead of doing a quadratic, do statistics calculations, and let's say it was an exponential function. So we're going to go over here and check. Your input variable is X, your output variable is Y. Whoops. And it's overriding the one we just did. So now our standard equation is A times B to the power of X, where this is A, this is B, and this is now R squared. So 0.46881, if I took the square root of that, I'm going to be able to find out what is my correlation coefficient. So again, what was that number? 0.46881. Oops. And there's my correlation coefficient. You see it's a little bit weaker, okay? Again, we want to get between as close to +1 or as close to -1, because you can have a decreasing function as well. The closer it is to -1 or 1, it is stronger and it's better. The closer it is to 0, it is weaker and it's just too random.